Not open session, sir. Solve with us.
Okay, then for open session, I need to ask for other instructor because they took the session, right? Solve the session which I took, I had uploaded only. So
Yes.
anyway, we will upload. Don't worry. Okay,
Yesterday,
so
yesterday session PDF, no, sir?
sorry, can you come again?
PDF is uploaded by you, taken in yesterday session.
Correct, correct, correct. The solve with the session which I took yesterday.
Yes, yes, sir, got it.
Okay. Okay, so we are live now. So let's start the revision of week 7 and 8. Is there any session along with this? I mean, simultaneously going on, or this is the only session?
No, sir. By 8 p.m. math session.
By 8 p.m., right? Okay,
Yeah.
we'll try to finish. Okay, so this is the revision session. Okay, so we will not go in that much depth which we are usually we do in our open session or solve with the session. Basically, it's just a revision session. Anyway, I will cover the all the concepts, and also I have collected the some questions which already had been asked, in the previous quiz 2 exam. Okay, so what we will do? Firstly, we will we will try to finish the content quickly because this is just a revision, and then we will try to solve the questions which has been already asked. Will that be okay for everyone?
Yes, sir.
Right, we'll try to see the concept which we have learned is the application of those concepts. Okay, so the things which we will cover in today's session. So first of all, we will see the sample mean. Okay, then we will see the sample variance, and basically then after this we will see what is the expected value of sample mean, variance of sample mean. Okay, similarly expected value of s square. Then next topic we will focus, that is called weak law of large numbers. Okay, so this weak law of large numbers, in short, we can say this is WLLN. Then we will move on moment generating function. Okay, so moment generating function in short we are saying is MGF, and then we will move see the final concept which is called central limit theorem. Okay, in short it is CLT. Okay, let's start. The very first thing I think we have seen, we will start, that is called IID. Okay, so the same thing, concept of IID we have learned yesterday also. So full form is independently and identically distributed. Okay, so yesterday I took one example, right? Suppose you are interested in to know the some characteristic of a rose plant, and then you have collected sample one, let's say, as uh, for the lotus plant, then from the lily plant, and etc. And second sample you collected from rose plant 1, there is another rose plant 2, and so on, right? And all these are independent. I mean, there is no connection in between these two. Then we decided, so which sample is good one? This one, right? Second one, correct? Because you can see, so this is the meaning of identical, right? So identically distributed means all the items in the sample are taken from the same probability distribution. You can see all the items in the sample are taken from the same probability distribution, then are all of taken from the rose plant only. Yes or no? So is the idea of this identical and independent is clear to all of you? What is the meaning of identically? Yes or no? So identically distributed means, I will say, all the items in this sample are taken from the same probability distribution. Is the technical definition clear to all of you?
Yes.
Right? And what do you mean by independence? So independence means they are not connected to each other in any way. Yes or no? Means
Yes.
there is no dependency. They are not connected to each other in any way. Okay. So that's why we are more inclined to this, what to say, this IID samples, right? So how we are defining? So let's say I'm saying x1, x2, so on, xn. So this is for from IID X. Okay. So you can see all are ID, and they all of them had taken from the this X distribution. So this X, this can be anything. Okay. For example, I'm saying X follows, let's say, Bernoulli distribution with parameter P. Okay. Then what will be the case? Suppose in general, for simplicity, let's say x1, x2 up to x5. This is follows Bernoulli P. Okay. Now, if I'm saying, let's say you collected the sample. Let's say Bernoulli P means I ask you to toss coin 5 times and observe the values, right? Then it can be 0, 1. Let's say 1, 0, 0. This is one of the possibility. Yes or no?
Yes.
Right. So this is again it can be something like that. You can get 1 0 1 0. That's also possible. Or 1 1 1 0 0. Possible or not? All these are possible, right?
Yes, sir.
So what is this? So these all things are called sampling instances, right? Okay. This is the technical word, sampling instances. So thing is, while we are writing small x1, so this is small x1, means this is one of the value of your capital X1. This is small x2, small x3, small x4, small x5. So that's why we are writing like this, because it can change. Okay. For different sampling instances, you will get the different values. Yes or no?
Yes.
Great. So if you see the sample mean, if I want to write the definition of sample mean, then how you can define? So suppose I'm saying let x1, x2 up to, in general, let's say xn be IID samples from a distribution. Okay, so as of now, we are writing in general. Let's say that distribution from distribution X. X can be anything. Bernoulli, binomial, Poisson, normal, it can be anything. So let's say with the mean mu, okay, and variance sigma square. Okay, so this will be with the, should write with mean mu. Okay. So this is the situation given to you. So how will you define the sample mean? So sample mean, basically, it's a very basic definition, as all of you know. X1 plus x2 plus so on xn divided by n. This is, I can write as x bar. Is this okay?
Yes, sir.
Now tell me whether x bar is a random variable or constant.
It's a random variable.
It's a random variable, right? Is there any reason why it's a random variable? Anyone?
Because it can be changed.
Correct. So for
Information.
different sampling instances, right? For this, you can get different x bar, right? For this, you will get different. I mean, anyways, for first and second, it's same, but for this, it's a different. So for different sampling instances, you can get the different value. So that's the property of a random variable. Yes or no? So x bar is a random variable. Does this okay? Yes, no, anything?
Yes.
Yes.
Now let's see some examples. Suppose I'm saying x1, x2, so on. Let's say x10, for example. This is follows IID. Now let's take this is from binomial. Let's say 3 comma half. Okay. All right. So can you tell me what is the expected value of x here? I mean, if x follows binomial, n
3
into
by
p,
2.
3 into 1 by 2.
that is 1.5.
5.
Now, so let's say if you did the first sampling, okay, and for this you got the output like this, anything, right? Let's say 3 0 0 1 1 2 1 0 2 1 is 10 3 3 6 9 10, right? This is possible.
Yes.
Okay. Then what will be the mean here? Anyone can you calculate? What will be the mean? If I will say some first sample mean.
1.1. It's coming out to be 1.1.
So this will be something like this: 2 plus 1 divided by 10. So
Yes.
1.1 because it's 11 by 10. Correct. And this is also possible. You went and you collected the data second time. So second sampling, you can get something different. So let's say it's a 2, 2, 1, 1, right? It's possible. 3, 2, 0, 0, 0, 2. So what will be the mean then? So basically, we
1.1.
have to add all these values, right? We have to add and we have to divide by 10. Anyone can confirm me why I'm taking only this kind of value 1, 2, 3. Why not 4?
It is binomial.
Binomial 3 comma half, right?
3.5. Yes.
Correct. So 4 to 6, 6, 9, 11 to 13. Correct. So now you can see for different sampling instances, you are getting different sample mean. Yes or no?
Yes.
So we can simply comment here this like sample mean, that is x bar, is also a random variable. Okay. Now, if this is the case, then there might be some questions. Let's say if this is the random variable, then I can find the expected value and variance. Yes or no? So we will see what is the expected value and the variance of x bar. Okay, anyone can tell me if I will write and you can confirm me. So suppose I'm saying let x1, x2, so on. This is all our IID samples. Okay, this all are ID samples from X. Okay, we don't know X here because we are going with in general. Okay, so this X has with mean, okay, mu. So this mean mu, what is this? This is distribution mean, right? Or you can say population mean. Okay, and let's say with variance sigma square.
Sir,
Okay.
I have a small query. Sir, would you just mind going up?
1 second. And suppose x bar is defined as like this. Yes, tell me.
Yeah, sir, in this you just asked like, why we are not taking, why it's not taking 4 as a,
In sample. As a
yes,
value
yes,
in my sample, right?
yes, I had a small query. Like, can you please explain like why it's not taking
What is this?
binomial 3 comma half?
If binomial, if x following binomial 3 comma half, then what is the value of n here? X can take value only 0, 1, 2 till 3,
Okay,
right? This
okay,
is correct.
okay, got it.
So if this is the case, so then I hope everyone would agree with me. So can I write expectation of x bar as a mu and variance of x bar as a sigma square by n? Is this clear to all of you, or should I do the reason behind? This is very important. Very, very important as your exam point of view also. So this should be in your mind.
Variance of x equal to x mu is divided by n is here.
This is variance of not x, variance of x bar.
Yeah, sorry. Variance of x bar equal to.
Is this clear to all of you? Should I do the derivation?
In denominator, it is a n or what?
It's a n.
N, okay.
Okay, let me do it quickly. So expectation of x bar is nothing but expectation of, I can write x1 plus x2 plus so on plus xn divided by n, right? Now I can write 1 upon n expectation of x1 in the numerator part, x1 expectation of x2 plus so on expectation of xn. Yes or no? So what is the numerator part? For each xi, what is the mean? Expected value of each xi is mu, right? Because all are IID. Expectation and variances will be same. Correct? It will be mu plus mu plus mu plus so on mu divided by n. Numerator part will be n mu divided by n. N will get cancelled, or which is mu. So expectation of x bar is nothing but mu, which I wrote here. Okay. Now, if you see the variance of x bar, so variance of x bar will be 1 upon n x1 plus x2 plus so on till xn, right? So we know variance of a times of x, a is constant, so it will be a square variance of x, correct? It will be 1 upon n square. Since all are independent, so I can write variance of x1 plus variance of x2 plus so on plus variance of xn. Yes or no?
Yes.
And what is the variance of each xi? Sigma
Sigma
square.
square.
Sigma
Because
square.
all are IID, right? So it will be n sigma square divided by n square. 1 n will get cancelled. Or it's a sigma square by n. Now it's clear from where it is coming?
Yes.
Yes, sir.
Okay. Now, so can you see from here? This will tend to 0 as n tending to infinity or not? I mean, when your n is large, you will get the lower variance, right?
Yes, sir.
So are you getting my point? So can I say having more samples, okay, I will get the better the prediction, right? Yes or no?
Yes.
Because there will be less variability, right? Are you getting my point?
Yes, sir.
Okay, great. For example, let's say I'm saying I have x1, x2, so on. Let's say x10. This is IID binomial for, let's say, for 9 comma 1 by 3. Okay. And my question is, you have to find the expected value of x bar and variance of x bar. So if you know the formula, you can do within a minute, right? So within a minute means, so what will be solution? And we know what is the expected value of x bar. This is mu. And what is mu? Mu is the distribution mean, right? Yes or no? So what the distribution mean? So n into
9 into 1 by 3.
9.
3, correct? And what is the variance of x bar? That is sigma square by n. So sigma square is what? Variance of this distribution, right? So it will be n into p into 1 minus p, which is 2 by 3, and n is 10. So basically it will be 2 by 10, that is 0.2. Are you getting?
Yes.
Right? This is clear to all of you.
Yes,
Yes,
sir.
Okay, great. Let me take another example. So this, see, don't take this kind of questions very lightly. These are important. Okay. So let's say I'm saying x1, x2, so on, x10. This is all are IID. Let's change the distribution. Let's say I'm saying these all are from exponential 5. Tell me what is the mu mean distribution mean? It's 1 by
1 by 5.
lambda. That is 1 by 5. What is the
Yes.
sigma square? 1 upon
1 upon lambda square.
25. Okay. So far so good. Now my question is, what is the expectation of x bar? It's a mu only.
1 upon 5.
You can see, if you know the formula, you will be able to do within a minute. Now variance of x bar, sigma square by n. What is the sigma square? 1 upon 25. What is the n? 10. 1 upon 250. It's clear?
Yes.
Yes, sir.
Yes or no? Suppose n is, instead of 10, I'm taking as 100. Then what will be the variance of x bar here? 1 upon 25 into 100, that is 1 upon 2500.
Very low variance.
If n is 1000, then what will the variance of x bar? 1 upon 25,000. So you can see, whenever n is large, if n is 10,000, right, then what will the variance of x bar? 1 upon this part. Now if you see, n is going to be large and variance is decreasing. Yes or no?
Yes.
That's what I wrote here. So if n is large, your variance will converge to the 0. Basically it will decrease. All right, any problem? So
No.
that's why we are, in real life scenario, we are much more interested to take the sample size as a large. Okay. So next concept is called sampling variance. Okay, basically sampling variance, or but if you, I can take, let's do it as a sample variance, and it's a s square. Notation is s square. So what is the basic definition? So x1, x2, so on, xn, this is IID sample, suppose. Okay. And I'm saying x bar is defined as a x1 plus x2 plus so on plus xn divided by n. Then the sample variance. I mean, how will you define your sample variance? Anyone can tell me what is the sample variance? Anyone?
Xi minus x bar whole square plus x2 minus x bar.
Right? Plus xn minus x bar whole square divided by n minus.
N minus 1.
This is the sample variance. One more thing. This is again random variable. Anyone can tell me why? Because for different kind of sampling instances, you will get different sample variance or not. So my question is, so if you can see for this sampling instance, you will get different sample variance, yes or no, for this one, and for
Yes.
this one your sample variance will get changed again, correct or not?
Yes, sir.
So
Yes, sir.
sample variance is also a random variable. The thing is, if this is the random variable, so what is the expected value of sample variance and variance of sample variance? So variance of s square is not in our course, but the expected value of s square is same as the sigma square. This is something you can keep in your mind. So what is this sigma square? This is basically, we can say this is distribution variance or population variance, right? We are saying. So if this is the case, maybe if if any one of you have watched the lectures of week 9, so from here, if this property holds, then we are saying s square is an unbiased estimator of sigma square, okay, which is population variance. Is this clear?
Yes.
Yes,
Okay.
sir.
Yes, sir.
So what you have observed, so basically as of now, if I would like to summarize, so expected value of x bar is mu, and expected value of s square is sigma square, right? So you can see the sample mean is an unbiased estimator of the population mean, and sample variance is an unbiased estimator of population variance. So don't worry if you are not getting the meaning of estimator and all, it will be clear in upcoming weeks, okay? But this is something you can keep in your mind. Okay, till this point it's clear, the rough idea is okay to everyone?
Yes, sir.
Okay,
Yes.
great. The next thing is called scaling and summing of the things. So let me write. So it's called scaling and summing. So what I mean by this part, okay, so let me write. So let x1, x2, so on till xn, okay, this all are independent. So now I'm not considering the IID part, I mean identical part, I'm just going with the independent part. So just wanted to showcase you how to proceed with if it's just independent, right? So suppose I'm saying I have defined s as a, let's say, a1 x1 plus a2 x2 plus so on plus a n xn. This is just independent, right? So then can you tell me what will be the expected value of s? I should write expectation of a1 x1 plus a2 x2 plus so on plus an xn. Can I write?
Yes,
Yes,
sir.
sir.
Right. So this will be then the next thing will be, I can write like this: expectation of a1 x1 plus expectation of a2 x2 plus so on plus expectation of an xn. Yes or no?
Yes,
So
sir.
from here,
Yes, sir.
can I write a1 expectation of x1 plus a2 expectation of x2 plus so on plus an expectation of xn?
Yes, sir.
Okay, this was just when xi's are independent. If, just suppose, if xi's are IID, then all expectation will be same, right? Basically, you will get a1 expectation of x plus a2 expectation of x plus so on an expectation of x. Would you agree with me? So expectation
Yes.
of x will be outside, and you will get a1 plus a2 plus so on till an. There is some background noise, so okay. Is this clear? This part, the difference between IID and independent part.
Yes.
What about variance of s? So variance of a1 x1 plus a2 x2 plus so on an xn, right? So since all xi's are independent, then I can write variance of x1 plus x2 as a variance of x1 plus variance of x2. Yes or no? This is true.
Yes, sir.
So basically, I can write variance of a1 x1 plus variance of a2 x2 plus so on plus variance of an xn. Then it will be, I can write a1 square variance of x1 plus a2 square variance of x2 plus so on an square variance of xn. Is this property clear? That's the answer, right? Yes or no?
Yes.
Yes,
If
sir.
xi is riid, then it will be a1 square. Variances will be same, right? Are you getting my point? Why I'm
Yes.
writing is the same? Because this
Yes.
is
Yes, sir.
IID, right?
Right.
So variance of x will be outside, and you can write a1 square plus a2 square plus so on plus an square. Till this point is clear?
Yes.
Yes.
Okay, great, great then, great. So the next thing, which okay, should I so the question related to this, or is this fine to move ahead?
Sir, can you provide the example?
Okay. Now, this is the one of the example. You can see the same property. Just consider this is S, and this is A1, X1, A2, X2, and A3, X3, right? So that's this property we have to apply. So here we have to find the variance of Y. So variance of Y means it will be variance of 2x1 plus 3x2 plus 4x3 plus 5x4. First of all, you can see all are IID, right? So this means, okay, first of all, what else I can write? Can I write 4 times of variance of x1 plus 9 times variance of x2? Are you getting? Because it's a
Yes.
square, right? Plus 25 times variance of x4. Is this clear?
Yes.
Since all xi's are IID, variances will be same. So it will be 4 times variance of x plus 9 times variance of x plus 16 times variance of x plus 25 times variance of x. So you can see it will be 4 plus 9 plus 16 plus 25 into variance of x. Yes or no?
Yes.
So this is 25, 25,
54.
50, 54 into what is the variance of x? So this is Bernoulli. So it will be p into 1 minus p. So 2 by 3 into 1 by 3. Yes or no? This is
Yes.
the variance.
Yes.
So this will be 2 by 9. So this is 6 times 6 into 2, that is 12, which is the answer. You can see you will get 3 marks out of 40. So basically out of 100, it will be 3 into 2.5. I mean, that is 7. Now you can see the property, how it's useful. Correct?
Yes.
Okay.
Formula will only be applied when in the question it will be mentioned that it is sample mean.
Sorry, can you come again?
So the formula which is sigma square by n, it will only be used when in the question it is mentioned that we have to
Correct,
find
correct, correct,
variance of sigma.
correct, correct, correct. So the next concept is weak law of large number. Okay, my question is to all of you, since you have done, don't worry about whether it's wrong or right. So can you tell me what the idea behind weak law of large number and what it tells us? Any thought, anybody? What you will get from here? Weak law from the weak law of large number.
When the sample increases, the sample mean approximately equal to the real mean.
Real mean, great. Anybody else? Any other thought? So the part is, first of all, this bound the probabilities. It will give you the bound for your probability.
Like
Okay, let's see.
expected probability.
Let's see. So suppose I'm saying x1. There is some background noise. Can you mute? This? Aditi, please. Aditi or Aditi? Yeah, thank you. If you doubt, you can unmute. That's not problem. So let's say x1, x2, so on xn. This is IID x. Okay. Now, if this is the IID x, I'm saying with expectation of x as a mu, and variance of x is variance of x is sigma square. Okay. Now, I'm defining x bar as a x1 plus x2 plus so on xn divided by n. Then in that case, since we have learned what will be the expectation of x bar, I would like to hear from all of you. This is
Mu.
mu. And variance of x bar?
Sigma square by n.
Sigma square by n.
Sigma square by n. Since this is IID, if this is independent, this sigma square n will not be right. That will be something different, right? Yes or no? Would you agree?
Yes.
Yes.
Now, my question is, this weak law of large number is helpful because it will give you the answer. If you are asking question, how will you quantify how close your x bar and mu are? Okay, like this basically, how will you quantify how close your x bar and mu are? Okay, so this is one of the question, right? This basically, can we say something more precise about x bar and mu? Basically, you are interested to know how close your x bar and mu are. Basically, you can say, so for this you want to put a number for this, right? I mean, you want to quantify, you want to put a number to check the like something more precise about x bar and mu. Okay, is this clear? Then what is the weak law of large number says? So probability that absolute difference between x bar minus mu greater than some quantity delta, this is less or equal to sigma square divided by n delta square. So since in the denominator n is there, so this will tend to 0 as n is large, means for large sample size. Okay, so are you getting the things here? If you see, you are checking the, is there you are interested to know the what is the probability that the absolute difference between x bar and mu are greater than some small quantity, right? You are quantifying how close your mu your x bar and mu are you getting my point? Yes or no? And the
Yes.
another I mean, in another form of this inequality is I can write x bar minus mu absolute difference. This is less than delta greater or equal to 1 minus sigma square divided by n delta square. Just think a bit. If you are not getting right now, you can think later also. If n is larger, then this will be 10. This will tend to 0. I mean this. I mean I'm talking about this particular term. Yes or no? If this tend to
Yes, sir.
0,
Yes.
this whole quantity will tend to 1.
Correct.
Yes, sir.
Yes.
So this means what? You are saying the absolute difference between sample mean and population mean is very less, right? And for this probability is close to 1. If okay, if for any event probability is 1, then what is that event called? What is the term for that event?
Success or
No, basically that's sure event, right?
surety. Yeah.
Surety, right? So somewhat you are sure about here, not exactly sure, but you are sure in probability. Means you are saying the absolute difference between the sample mean and the distribution mean is very less, and for this probability is close to 1. Correct?
Yes, sir.
Right? So the thing, you can think like this. So suppose let me draw something, and suppose this is mu minus delta, and this is mu plus delta, and let's say this is somewhat mu is here. Okay, this is mu. So what is the part, I mean, where you are interested? So you are interested in what is the x bar minus basically this delta. So here x bar, you are interested whether your x bar minus mu, okay, or let me write it, whether x bar is greater than mu plus delta, or x
Yes.
bar is less than mu minus delta. Yes or no? Are you getting my point? That's your
Oh
question.
no, sir. X would be greater than mu minus delta and less than mu plus delta, na?
If x bar I'm writing here, then x bar is less than, right?
Oh, you are writing x bar, then less than.
Okay, from here, what you can say, x bar minus mu greater than delta, or x bar minus mu less than minus delta. Yes or no? So if you see this part, I can write absolute difference of x bar minus mu greater than delta or not.
Yes, sir.
Okay. The same thing is here. Okay. So you can think like this. So the key thing is this weak law of large number, the formula, this formula you can get from the uh, Chebyshev inequality. Okay, sometimes it will be mentioned as Chebyshev inequality also. So how you can find from the Chebyshev inequality? Let me show you in a minute. So what is Chebyshev inequality? If I will write probability that x minus mu greater than some epsilon less than or equal to variance of x divided by epsilon square. This is one of the formula. Yes or no? So here we are dealing with the x only. Let's say I'm going for x bar because in weak law of large number we are dealing with the x bar. So if I will write probability that x bar minus mu, okay, this will be expectation of x bar will be mu only, right? Greater than epsilon less or equal to variance of x bar divided by epsilon square. So far so good.
Yes, sir.
What is the variance of x bar?
Variance of x divided by n.
Sigma square by n
By n, yes, sir.
into delta square. Sorry, epsilon square. And what is the weak law of large number says? Probability that absolute difference x bar minus mu greater than delta less or equal to sigma square is n delta square. Both are same.
Yes, sir.
Okay. And what is this? This will give you the upper bound. This is upper bound, right?
Yes.
Okay. Is this clear? So here you will say when n is large, this will converge to 0. Basically, you are saying probability that more absolute difference between x bar and mu, this is close to 0. Then you will say x bar is close to mu. Yes or no? Means probability of a null event is 0, right? So this means you are denying this part. The absolute difference between x bar and mu is greater than some quantity. You are denying this part because probability is 0 for this part. Yes or no?
Yes,
Right? Is the idea clear?
yes, sir.
Okay, great. So let's see some example related to this. I will take one example, then I will move ahead. Okay. So let's say I'm saying x1, x2, so on, x50. This is IID, Bernoulli, 3 by 5. I mean, success is 3, success probability 3 by 5. This is Bernoulli. So my question is, you have to find a lower bound, okay, not upper bound. So that means we have to use the second form, right? On the probability that the sample mean lies in 0.5 comma 0.7. Okay, so this is about lower bound, right? Yes or no? So if you see the form of weak law of large number, so probability that absolute difference between x bar minus mu greater than the sum delta less or equal to sigma square divided by n delta square. This is upper bound. Yes or no?
Yes.
And we have to go for the lower bound. So lower bound is this part. So
Yes.
lower bound will be probability that mod of x minus mu less than delta greater or equal to 1 minus sigma square by n delta square. This is lower bound. Yes or no?
Yes, sir.
So what you can see basically from here, can I write this as a probability that minus delta less than x bar minus mu less than delta greater or equal to 1 minus sigma square divided by n delta square? Can I write or not? From here, can I write probability mu minus delta less than x bar less than mu plus delta greater or equal to 1 minus sigma square divided by n delta square? Yes or no?
Yes.
Yes, sir.
So here you can see what is the question. In the question it says this probability that sample mean lies in 0.5 and 0.7. That means it is asking probability that sample mean is lies 0.5 and 0.7. Yes or no? So that means can I say mu minus delta is equal to 0.5?
Yes, sir.
Yes or no?
Yes, sir.
And what is the mu? What is the mu? Mu means distribution mean. So this is P, which is 3 by 5 only.
Into 50.
So this is 3 by 5 minus delta equal to 0.5. So what will be the value of delta? Delta will be 3 by 5 minus 0.5, 0.1,
Yes.
Yes, sir.
right? So we got the value of delta. We have to calculate the value of sigma square, right? So from the distribution only, what is the value of sigma square? So it will be P into 1 minus P.
1 minus p.
It's by 25.
So basically, sigma square will be P into 1 minus P. So it's 3 by 5 minus
6 by 25.
6 by 25, right? Now, what we have to do? So this will be greater or equal to 1 minus. What is the value of sigma square? 6 divided by 25. What is the value of n? N is 50. Are you getting what I'm doing here? Into delta square is 0.1 square. Correct?
Yes.
Yes.
So just you to solve this value, you will get the answer. Okay?
Sir.
Hmm.
So there's a doubt, sir. When you say x1, x2, dot 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 xn is IID of Bernoulli 3 by 5.
Uh-huh.
So basically, you're saying that each of them will have that probability 3 by 5
Huh?
of occurrence. So how come we are having the population mean as 3 by 5? Sorry, the population, yeah.
Yes, so this is the population mean. You are saying you have collected this sample from this population. Okay? So this is the population mean. And for Bernoulli, mean is P, right? So I mean, expected value of X is P here. This is 3 by 5. Got it?
Okay, sir. Actually,
Okay.
I
This
thought
is,
it was n into p, so that's why the
no.
problem.
Okay. It's
So
clear?
it in the bound of minus delta comma delta, no?
Sorry?
The bound should be minus delta comma delta.
Minus delta comma delta. No. So this is mu minus delta and mu plus delta.
Oh,
You can see X bar is lies between mu minus delta and mu plus delta. Okay?
okay, sir.
Clear?
Hmm.
Okay. Is this clear to all of you? So I have some questions. Let me solve this and we can move ahead. Okay. What about this part? How will you proceed? It says, suppose iron rods are manufactured with a mean weight of 10 kg. So let's say expected value of X is 10. I mean, X represents the, let's say, that part. And very standard deviation is 0.4 kg. That is sigma is 0.4 kg. Yes or no? So what will sigma square? 0.4 square, right? So if you see, it is asking you how does the variance of the sample mean change when sample size is decreased from 64 to 25.
So,
First
sir,
of all,
it is
what
asking
is
for
the
sample variance, no?
variance? No, variance of sample mean. Just read this English part, right? Variance of the sample mean. That is variance of X bar, and we know this is sigma
Sigma
square
square
by,
by n.
N.
correct. So you have to just calculate when n is 64, then what will be sigma square by n? What is the sigma square? This is 0.4 square and n is 64. What will the value?
0.0025.
0.0025. And if n is 25, then sigma square by n will be 0.4 square divided by 25. So this is 0064. So you can see variance is increased when sample size is decreased. So option B is correct. Fine. So you can see how simple is it. Where it went. Yeah, correct. What about this part? So this kind of questions we have done. I mean, this concept we have learned. But tell me, what about this part? If exponents, it is asking expected value of y. So first of all, it will be summation I is equal to 1 to 8. Expected value of xi plus 2 times summation I is equal to 9 to 16. Expected value of xi. So what is the expected value from here? Expected value of x?
1 by lambda.
1 by 2, basically, right? So this will be summation I is equal to 1 to 8, 1 by 2 plus 2 times summation I is equal to 9 to 16, 1 by 2, correct? So it will be 8 by 2 plus 2 times, tell me what should I write?
16.
9 plus 10 plus till 16 by 2.
8 into
How many times? 7 times or 8 times?
7
8.
times.
8.
8 times.
8.
Just see. Okay, so this will be 4 and this is 4 plus 8, which is answer C. How simple is it? Correct?
Yes.
Now,
Means the sum I can't get.
which one?
The point. The sum.
This one.
Hmm.
Just count from 9 to 16. It's a very counting, very simple thing. Counting now 9 to 16. How many numbers are coming?
7.
9 is
How-
included now.
Including 9 and 16. 8 times.
Including 9, na?
You are finding the difference. I'm just saying, just count.
Oh, then sir, it will come as 8, I think.
And not, I think it's correct. 8 should be there. So the smart approach is you can simply do like this. So 16
Means
minus
we have
9.
to count 16 and 9 both, or the difference.
What is it? Summation is going from where to where? Tell me.
9 to 16.
That means what?
9 plus 10 plus that's the process.
That's the process. But how many times you are adding? This means what? You are adding 1 by 2, 1 by 2, 1 by 2. How many times? Suppose this is 9, this is 10, this is 11. How many times? 8 times or 16?
8 times.
That's what I written, right? This is a constant. Understood?
So sir, 8 times it should be, sir, then
Half. 8 times half.
8 times half, right?
Hmm.
That's what I have written.
Oh, it is theta or 8?
8.
Like theta, sir.
No. I'm not going to discuss that now. So this is see,
Okay,
there is no
sorry.
theta in the question.
I can't see properly there. Oh, that's why, sir.
This is 8. This is 8. See, you can see if you will add. So this means you are adding 1 by 2, 1 by 2, 1 by 2, 1 by 2 till 8 times. Because if you see, this is very basic thing, right? 9, 10, 11, 12, 13, 14, 15, 16. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, right? Now it's clear?
Yes, sir, clear.
Okay, that's what. Yeah, correct. So next question is, if you will be using the Chebyshev inequality, you have to find the upper bound for this quantity, right? So where x bar is the sample mean. Okay, this is the 16 sample you have taken. I mean, and this is the sub part of this part actually. This is from exponential lambda equal to 2. So I'm just writing here. So I will give you the 2 minutes to all of you. Just do this and tell me whether you are getting the same answer or not. That is 0.5. Are you trying, right? I'm assuming everyone is trying.
Yes, sir.
Okay, yeah. Please do it and do let me know what is the number. I mean, whether you are getting the same number or not.
Yes, sir. The mean is same as 0.5.
I'm not asking about mean. What is the question? It is asking about upper bound.
Okay.
So probability that mod of x bar minus mu greater than epsilon less or equal to variance of x bar divided by
It's coming
epsilon
0.25,
square,
sir.
right? That's property. So probability that absolute value of x bar minus mu greater than epsilon less or equal to variance of x bar will be sigma square by n into delta epsilon square. So far so good.
Yes.
Now if you see what is the x bar, x bar is there. What is the mu?
0.5.
0.5 is already there, right?
Yes.
Give me 1 minute. Okay. So that means what is our delta? 0.25.
0.25.
And what is the sigma square in case of exponential distribution? It's 1 by lambda square. That is
1
1
by 4.
4.
1 by 4.
So this will be sigma square is 1 by 4. And what is the value of n?
16.
What is sample size is 16. And what is the epsilon square? This will be 0.25.
Square.
So
Whole
if you will solve this, it will
0.25.
be 1 by 4, which is 0.25. This is how simple is it? Correct? Got it?
So, sir, epsilon is 0.25 square.
Yeah. Because in the question it is given that 0.25. Okay?
Hmm.
Clear to everyone?
And sir, how are you getting the 16? Value of n.
16 is a sample size, value of n.
Hmm.
16 is given in your question.
And sigma is 1 by mu.
Not 1 by mean, it's 1 by 4, 1 by lambda square in case of exponential distribution. Okay?
Okay.
Yes, no?
Yes, sir, got it.
Okay,
Yes.
great. Okay, the next concept, let me start. Let me finish the concept first, then we will move at to discuss the questions. Okay, as of now, all things are clear. Whatever the things we have discussed and the questions related to those concepts. Okay, great.
Yes.
The next concept is called moment generating function. Okay. Okay, short form for this is called MGF. Okay, great. So what is the MGF? How will you define? So MGF is something, let X be a random variable. Okay. The MGF of X is nothing but basically this is a function from R to R, and which is defined as the proper definition of mx lambda is expectation of e raised power lambda x. Okay, so this is the general definition. Okay, the thing is, whenever you, okay, what is the moments basically, if you'll see, if you expected value of x called the first moment. Okay, and expected value of x square is called the second moment, and expected value of x cube called the third moment, and expected value of x raised power 4 called the fourth moment. Okay, similarly, if expected value of x raised power k, then it will be called the kth moment. Okay, yesterday I discussed this is helpful to find the skewness and kurtosis, but anyway, that's not in our course. Now we will see the things which is in our course basically. So this mgf is very very helpful to uniquely determine the distributions and all. Okay, so if you see the formula, let me tell you, if x is discrete random variable, okay, with let's say PMF probability x equal to x and some range tx, okay, then mx lambda is what? Expected value of e raised power lambda x. Then how will you write? How will you define expected value of x in case of discrete? Summation of x into probability x equal to x, right? So this will be summation of e raised power lambda x into probability x equal to x. Yes or no?
Yes.
Okay. Then it should, this summation should exist. Okay. And if x is a continuous random variable with PDF f of x, then mx lambda equal to expectation of e raised power lambda x, and we know how to calculate expectation of x for continuous random variable, e raised power lambda x f of x dx. Okay, would you agree with me?
Yes.
Yes, sir.
Great. Let's see some example, then I will move. Okay, suppose I'm saying x is following something like this, -1 0 1, and since this is uniform, let's say this is discrete uniform, so all the probability will be same.
Yes.
Now my question is, if I will ask to you what is the mx lambda, that is expectation of e raised power lambda x, since this is discrete, I will continue something like that, summation of e raised power lambda x into probability that x equal to x.
Yes, which is an f of x of x.
F of x of x, that's the difference of notation, correct?
Hmm.
So here I can write e raised power lambda into -1, right, into 1 by 3. See,
Yes.
these are the
Yes.
possible values of x, right? plus I will write e raised power lambda into 0 into 1 by 3
Yes, sir.
Yes, sir.
plus e raised power lambda into 1 by 3. Would you agree with me?
Yes.
Yes, sir. Exactly.
So what is the things we are getting? We are getting e raised power minus lambda into 1 by 3 and
Yes.
e raised power 0 will be 1. So 1 by 3 plus e raised power lambda into 1 by 3.
Yes,
Is
sir.
this clear?
Yes, sir. Yes.
Yes.
Okay. One more thing you can observe from here. Okay, I will explain it later.
अच्छा
Uh,
सर, क्वेश्चन में अब जैसे ये मैंने बहुत जगह देखा है कि जो कोफिशिएंट है आगे वाला वो दिया रहता है, क्या क्वेश्चन में भी दिया रहेगा हर समय ये
which coefficient you are talking?
1/3?
So if it's not given, then distribution will be mentioned. Suppose I am writing x is following discrete uniform distribution with minus 101. That's a very basic thing. Then all the probability will be same. Okay. Okay.
Yes, sir.
So suppose I'm saying x follows x is taking some value minus 2 and 1, and with the probability, let's say 1 by 4, 3 by 4. So here see, it is clearly mentioned this is not a discrete uniform or something like that. It's something different. Okay. If I will ask what is the mx of lambda, okay, then it will be expectation of e raised power lambda x, then summation of e raised power lambda x into probability of x equal to x. What it will be? Can you tell me? Tell me, what should I write? E raised power
minus 2 lambda
into 1
into
by
1
4
by 4
plus e raised power lambda into
3 by 4.
very good. One more thing you can observe, if mgf is given to you, you can find the pmf. Yes or no? How? I will give you I will tell you. Suppose mx lambda is given to you as, let's say, e raised power minus 2 lambda into 1 by 3, for example, plus 1 by 3 plus e raised power 2 lambda into 1 by 3. So can I write like this, e raised power minus 2 lambda into 1 by 3 and e raised power lambda into 0 into 1 by 3 plus e raised power 2 lambda into 1 by 3. Would you agree with me? Can I write like this?
Yes, sir.
What is this? This is nothing but e raised power lambda x into probability of x equal to x.
Yes.
What is the possible values of x here? Minus 2 with probability
1 by 3.
1 by
1 by 3.
0, 1 by 3.
1 by 3.
2, 1 by 3. So you can find the distribution or not?
Yes, sir.
Correct? So basically, if from the MGF, you can find the distribution of x, and if the distribution is given to you, you can find the MGF. Okay? Clear? Clear to all of you?
Yes.
Okay. One more thing, if suppose there is a twist I mean, suppose I ask what is the MGF of centralized version of x, then how will you proceed?
We will subtract p from every.
Suppose I'm saying x is defined as a, let's say, Bernoulli half. So this means x is taking value 0, 1 with 1 by 2, 1 by 2. So far so good.
Yes.
Right? Now my question is, find the MGF of centralized version of x. Okay, so what do you mean by centralized version? So centralized version is nothing but, I'm saying, let's say I'm defining y as a x minus expected value of x.
Yes.
This is centralized version of x. Everyone is would you agree with me?
Yes.
Okay, so this means what? You have to calculate the MGF of y, not MGF of x. Are you getting my point? So what will be the MGF of y? First of all, you have to calculate the values of y, right? If okay, first of all, what is the expected value of x in case of Bernoulli half?
Half.
Expected value of x is half, that, right? So what will be the value of y? If you see,
Minus half, and
so it will be 0 minus half. So minus half and 1 minus half.
half.
Yes or no? And what is the probabilities for each wise? 1 by 2.
1 by 2.
Be sure this is the values and these are the probabilities. And what will be the my lambda then? Expectation of e raised power lambda y, that is summation of e raised power lambda y into probability of y equal to y. So it will be e raised power minus lambda by 2 into 1 by 2 plus e raised power lambda by 2 into 1 by 2. Is this clear?
Sir,
Can you explain y equal to minus 1 by 2 and 1 by 2?
What is this? How we are defining y?
Yes, yes, sir.
X minus expectation of x, right?
Okay,
What
here
is
value of expectations of x is 1 by 2. Value of x is?
X is 0 and 1.
Yeah.
This is Bernoulli. So if you
Okay.
subtract 0 minus half, you will get minus half. 1 minus 1 by 2. 1 by 2.
Okay, got it.
Sir,
Got it?
and this P y equal to y, it will stay as the original Bernoulli only, right?
Yeah. Probability will not change, right? Probability
Not
won't
change.
change. Okay. One more thing. What if I will ask to all of you, one more thing you have to keep in your mind. Okay. So let's say I'm saying, suppose you have defined y as a x1 plus x2. Okay. And x1 and x2, these two are independent. Okay. All right. Then my question is, my lambda, what will be my lambda? This means expectation of e raised power lambda y. Yes or no? So this means
Correct.
expectation of e raised power lambda x1 plus x2. Can I write?
Yes, sir.
Yes.
If this is the case, can I write expectation of e raised power lambda x1 plus lambda x2?
Yes, sir.
अच्छा, सर की आवाज सबको सुनाई दे रही है क्या?
नहीं.
लगता है सर कहीं गए हैं. So friends, how are your quiz to preparation is going? Hello?
Hello. Hello. Can you hear me?
Yes, sir.
In between, give me a minute. I will share my screen and the page where we were discussing. my actually my system got you know say closed in between, but yeah, but the one issue, whatever the things I wrote, it was not saved. So anyway, I will upload this PDF of questions, and I will try to upload the PDF of some last term. Okay, will that be fine? Because whatever the things I wrote, system got suddenly disconnected. And whatever the things I discussed, it got unsaved. Okay, sorry about that.
Oh, sir, no problem, sir. You can arrange the solution and send. No problem.
Okay, okay.
No
So
need
not
to, no need to hide for.
okay. Anyway, we will discuss these questions, and what I will do, I will see the some PDF from the last term, and I will upload there. Okay.
Yes, sir. That's the good, sir.
Oh.
Yes, sir.
So we were discussing, suppose in the case of MGF only, right? So if y is defined as x1 plus x2, and this x1 and x2, these two are independent, right? We were at this point. So if I want to find the MGF of y, then it will be expectation of e raised power lambda y. I can write expectation of e raised power lambda x1 plus x2, correct? Then I can write e raised power lambda x1 plus lambda x2. And can I write this as a e raised power lambda x1 into e raised power lambda x2? Yes or no? Since x1 and x2 are independent, then I can write expectation of e raised power lambda x1 into expectation of e raised power lambda x2 or not. We know if x and y are independent. Oh, sorry. If we know if x and y are independent, then we can write expectation of x into y as a expectation of x into expectation of y, correct? So what is this? M x1 lambda into M x2 lambda? Yes or no? So you can see My lambda is nothing but mx1 lambda into mx2 lambda. So we can say the MGF of sum of two random variable is same as the product of their individual MGFs, right? So this was when x1 and x2 are independent. If I'm saying x1 and x2 are IID, so if these two are IID, that means what? Expectation value will be same, that then MGF will be same. Then can I write My lambda as a mx lambda whole square? Would you agree with me?
Yes, sir.
Right? And if you have n random variable, let's say x1 up to xn, these all are IID, then My lambda, where y is nothing but summation of each xi, is will be mx lambda raised power whole n. Yes or no?
Yes, sir.
One more thing, if x follows, which is very, very important, normal 0 comma sigma square, then what is the value of mx lambda? E raised power lambda square sigma square by
2.
this is something you can keep in your mind. Okay, is this fine till now?
Yes.
Okay. The next concept is called central limit theorem. Okay, the same thing I think we have discussed yesterday also in detail. Yes or no? So if you give me a second, if you want to know more clarification on this central limit theorem part, you can refer the yesterday's lecture video. But anyway, yesterday I showed some R code animation also. You can refer to that yesterday's video, but I will quickly go through this central limit theorem also. That's not a problem. Okay, so what is the central limit theorem says? Okay, first of all, what is the role of central limit theorem? This approximate the probability, right? This is approximating the probability. Okay, now how we will see? Suppose I'm saying x1, x2, so on, xn, this all are IID x. Okay, and let's say with expected value of x is 0 and variance of x is sigma square. I'm taking like this. Okay, and suppose I'm saying y is defined as a x1 plus x2 plus so on plus xn divided by square root of n, then my lambda, I mean basically mgf of this y will be e raised power lambda square sigma square divided by 2. That means I can say, and this mgf is of normal. Can I say y is set to converge to normal 0 comma sigma square. So what is the key idea? For a large n, the distribution will be, I mean, suppose summation of xi is or x1 xi is divided by square root of n, or xi is divided by n, I mean x bar and all. Distribution of this, if you will convert in standard form, then it will be the normal 0 comma 1. Okay. Yes or no? Is this clear, idea clear or not? So let me show you how to, using CLT, how will you approximate the probability. Okay. Now the same thing I did yesterday, but just a quick recap. So x1, x2, xn. Okay. So this all are IID x. Okay. Let's say in general I'm saying with expectation of x is mu and variance of x is sigma square. Now my question is, let's say I'm defining y as a x1 plus x2 so on plus xn. Tell me what will be the expected value of y here?
N mu.
N mu, right? You have to add expectation of x1 plus expectation of x2 plus expectation of xn. What is the variance of y?
n n sigma square.
And sigma square, right? That's a very simple thing. So what you have to do, then z equal to y minus expected value of y divided by standard deviation of y will follow normal 0 comma 1. Okay, this is central limit of n is large for a large sample. So what it will be? It will be y minus n mu divided by square root of n into sigma. This will follow normal 0 comma 1. Is this clear? Yes or no? So what you have to do, whenever you are getting the questions related to central limit theorem, you have to convert into standard form, standard normal form.
Sir,
Yes or no?
one question is here. Here, normal 0, comma 1 instead of 0, 1, any other value. Then
Instead of no, this is normal 0 comma 1. If you are converting like this, right,
yeah,
you will get the normal 0 1 always. You can
always.
find. So this 0 is expected value of z, right? So if you will do expected value of this part. Okay, let me do right. So expected value of y minus, let's say this is mu only, right?
Yeah.
Sorry, n mu divided by standard deviation of y. So what is the expected value of y here? N mu. So n mu minus n mu, this will be 0.
0.
If you
Yes.
do variance, then variance again will be sorry, standard deviation. Then there, if you will do right, standard deviation of y minus expectation of y divided by standard deviation of y. So this is one quantity. This is fixed quantity, for example. Okay. So there is no effect adding or subtracting on variance and standard deviation. Numerator part will be standard deviation of y. Denominator standard deviation of 1. Okay.
Yes.
So if you are doing like this, it will be normal 0 comma 1. So you can find the normal 0 comma sigma square also. This sigma square will be here only. Here it will be only square root of n.
Okay.
Understood? So let's say I'm saying if y equal to x1 plus x2 plus so on plus xn divided by n. You have to approximate the probability by using the central limit theorem. Can you tell me this is sample mean? Y is nothing but sample mean here. What will be the expectation of y here? What is the variance of y?
Sigma square by n.
Sigma square by n, right? Now, if you will apply the central limit theorem, then y minus expectation of y divided by standard deviation of y, this will be normal 0 comma 1 by CLT. Yes or no?
Yes, sir.
Yes.
So this y minus mu, what is the standard deviation of y? Sigma divided by root 10 will follow normal 0 comma 1.
Yes.
Or basically you can say x bar minus mu divided by sigma by root 10. Anyway, that's both are the same. Normal 0 comma 1. So that's the central limit theorem.
Sir, I have a doubt. Small doubt
Yes.
related to CLT. Is
Huh?
it applied only when the value of n should be greater than equal to 30?
Correct. It's CLT is for large sample. Yesterday I have shown. So what you can do, just go and rewatch the yesterday lecture for first few minutes. It will be clear. So I showed one animation. Okay. Through that animation, if you will increase the sample size, when n will increase, your I mean the graph will converge to the normal distribution.
Normal distribution, the bell curve.
Correct. The thing what we are saying, suppose, I mean, what is the key idea? It converts to normal distribution means, suppose x bar is, let's say, for example, suppose mu is 1. Okay. Just assume mu is 1. And then if you increase the sample size, right? So by the central limit theorem, your x bar will also be close to 1 if n is large. Okay.
Okay.
Sir,
Okay. Yes.
sir, can you just go above?
Okay.
Yeah. So
Sorry about this. Yes.
So basically, like in one case we have taken y as x as the sample mean, and in another one we have taken as y as the sum of the. Okay. So basically these are two different cases.
Correct. It can vary. I can do x1 plus x2 divided by 2, something like that. Okay. The thing was, what I wanted to show you, you have to do this. You have to keep in mind this property: y minus expectation of y divided by standard deviation of y will be normal 0, 1. So this y can be any form. Basically, you have to find the expected value of y, that particular form, and standard deviation of that particular form.
Okay. It can be in this form also. Sum of all the
Correct.
individual
Anything, square root of, divide by square root of and something like that. Okay. So let's see some questions. Okay. Then I will move to the. So actually we are done with the major concept of week 7 and 8. Let me show you something. Okay. Just this is very simple thing. Just read this question and tell me. Anyway, answer is visible to you. Can you tell me why B is correct?
Because they are given that defective eyesight is 20% and they're asking for normal eyesight, so the probability will be 1 minus 20 by 100.
So if you see, this is 20%, right, for defective, correct? So if you're considering as a P, then what will be for normal eyesight? That is 1 minus P, that is 0.8. Okay.
Yes.
If you see, X denote the total number of children who have normal eyesight in the selected sample. And what is the size of selected sample? This is 400. So it will be X will follow binomial 400, 0.8. Is this clear? Sometimes people in hurry, when people are in hurry, they will correct with this, but you have to read the statement carefully. Okay, is this clear?
Yes.
Great. Now the next question is based on the 1 second. Yeah, I have to fix this, but let's try to manage. Okay, so you can see it is asking, using the central limit theorem, find the approximate probability that in a random sample of 400 selected children, at least 80 will have the defective eyesight. Okay, that means what it says, you have to find the probability that x is greater or equal to 80. Since sample size is large, I will use the central limit theorem. First of all, what is the like P? What is the mu? I mean distribution mean. If you see, this is binomial, right? See, x is binomial. Yes or no? Let's say let's define as x let's define as y, because x is for normal eyesight in the question. Okay, let's say this is y. So y is binomial. For defective eyesight, it will be 400, 0.2.
Yes.
Yes or no? What will the mu? Because we need expected value of y, right? This is NP.
Yes.
So 400.2, which is 80.
Correct.
Everyone is getting my point. And what is the variance of y? N into P into 1 minus P. Then 400 into 0.2 into 0.8. So 80 into 0.8, that is something 6.4, if I'm not wrong.
Yes, sir.
64, sir.
64, sorry, 64. Right? So if you see what we have to do next task, I have to convert it to standard form. So this will be y minus expectation of y. I have to do on both sides 80 minus expectation of y. Yes or no? I have to divide by standard deviation of y. I have to divide by standard deviation of y. Yes or no?
Yes.
So this will be probability, and this circle one I can write as a g greater or equal to 80 minus what is the expected value of y? 80 divided by standard deviation of y. No need to
Root
substitute.
under of 64, sir.
So probability z is greater or equal to 0, 80 minus 80. Okay. In this case, you can see what is the value of probability z is greater than 0. Since this is the standard normal curve, okay, z is standard normal distribution, mean is 0, and then probability of this part will be same as probability of this part or not? Because of symmetricity.
Yes.
So
Yes.
this will be 0.5 direct. Okay.
Okay, sir.
Is this clear? Idea is clear to all of you?
Yes, sir.
Okay, great. Let's see the next question.
Sir, this question is from beta distribution, na?
Binomial.
Hmm?
Binomial, not beta.
Okay.
So read this question and tell me which option is correct and why.
Sir, option number B.
Okay, I got one vote for option number B. Okay. Anybody else?
So one, no? First A option.
Okay, one
A.
vote for option number A.
A.
One vote for option number A. Yes.
Sir, A is coming.
A is coming. Okay. Anybody else? Anybody? Any other answer, or are you okay with option number A? Okay, someone is saying A and C. Okay. Majority is going with option number A. Anybody else? No one? Okay, see. None of all are incorrect. D is correct. So the reason behind it, if you read the question carefully, okay, read the question carefully, it is asking about, first of all, what will be a acceptable approximate model for x as per the central limit theorem, right? So we know as per the central limit theorem, for large sample size, it will follow normal distribution. Yes or no? Yes or no? This will be normal distribution.
Yes.
Right? This is as per the central limit theorem. Now, this will follow normal distribution. We have to find the mean and variance. We have to cross check this mean and variance. Okay. First of all, here you can define like this: each xi is follow exponential distribution with parameter 10. Sorry, this is mean. Mean is 10, right? So 0.1. Yes or no?
Yes, sir.
Yes or no? So mean is, so expectation of each xi is what? 10. Variance of each xi is what? This is 1 by lambda.
Yes.
1 by lambda will be 100. 1 by lambda square will be 100. Yes or no?
Yes.
Yes or no? Now, if you see, x is represents the what? Total service time for 100 customers. So that is xi is equal to 1 to 100 xi.
Yes.
Yes or no? So now you have to calculate the expected value of x. So expected value of x, summation I is equal to 1 to 100. Expected value of xi. So this will be I is equal to 1 to 100. Each xi is 10. So this will be 100 into 10, which is 1000. Yes or no? And variance of x will be summation of I is equal to 1 to 100, variance of each xi, summation of I is equal to 1 to 100, which is 100. So it will be 100 into 100, which is 100 square. So that's why option number D is correct. Is this clear?
Yes, sir.
So you can see in the question, it is clearly mentioned what is the acceptable approximate model for x as per the central limit theorem. Okay. Yes, no?
Sir, can you please show the answer again? Just.
Okay, clear?
Yes, sir, clear.
Okay. Now, the next part is, you have to, using the central limit theorem, you have to find the approximate probability that the total service time for 100 customers exceed 1200 minutes. So what do you mean by this line? What should I write mathematically? Tell me. What should I write?
Probability of x is greater than 1200.
Right? This is something we have to calculate, right? So we know x follows normal 1000, 100 square, right? This is something we have calculated. Now, by using this information, can you calculate and tell me the at least till fz? What is the value you are getting? I will let you the answer. Okay, everyone has pen and paper. Can you calculate and let me know? At least till fz, what are the things you are getting? Fz of what value?
Sir,
So
it
Z
is
is greater than 0.02.
Sorry?
Or 0.02.
I don't know. I need to calculate then. Anybody else?
1 minus fz of 2.
Fz of?
Z02, yes.
Okay, great. So yeah, so this is something. Can I write probability x minus, I have to do expected value of x divided by standard deviation of x, right? Same thing on right hand side also. Yes or no? So if you see, this is nothing but this will be z. So z greater than 1200 minus 1000. What is the standard deviation? It will be 100 only.
Yes.
So this will be probability z greater than 1200 minus 1000, which is 200 divided by 100. So this is nothing but probability z greater than 2, right?
Yes.
And this is something I can write 1 minus probability z less or equal to 2. So 1 minus fz of 2. So basically fz of value of fz of 2 is 1 minus 0.977. This value will be given to you, okay? And the answer will be 0.02 because of till 2 decimal places. Okay, is this clear? Now you got the idea how to approach for the central limit theorem and reason behind the central limit theorem. Yes or no? Yes, no, anybody? Are you getting or not? What are the things?
yes, sir.
Okay.
Yes.
I think this problem we have solved already. This one also we solved. Now tell me for this question. Option number 3 is correct, but why?
Because the question is asking for the bad quality.
Sir, option C is correct because 1 minus 60 by 100 it should be.
1 minus 60 by 100, that's correct for bad quality. But why 20? It should be 600, right?
No, sir.
No, because of a sample of 20 bottles we are selecting, right?
Sample is
Correct.
Sample of 20 bottles.
So it will be x follows binomial. So here you can see we didn't mention what will be the approximate model. So if you find the difference between the above one, it's not a follows normal one, because we didn't mention about the approximate model as per the central limit theorem. We are simply asking what will be the distribution of f. Is the difference clear?
So
Yes.
so basically in the first question, the
Hmm.
previous one.
Hmm.
So we have been given a binomial model and we are trying to convert into a normal model using
Correct. So,
CLT.
yeah.
And in the second, we are in binomial itself, representing the entire thing as a binomial
See,
model.
Correct. So in general, see, in reality, it will follow x follows binomial n comma phi, whatever the sample size of n, whatever the values of p, right? But if I'm
Yes.
mentioning what will be the approximate model as per the central limit theorem, that means what? If I'm talking about central limit theorem, that means it will follow the normal distribution with some mean mu and some variance sigma square. Yes or no?
Yes, sir.
Yes,
Yes, sir.
yes.
Yes.
Are you getting the difference, right? So
Yes.
this option is correct. Now you have to apply the central limit theorem. N is 600 in total, because we have to apply the central limit theorem for the total. And what is the probability of being a good quality? It's a 0.6.
0.4.
0.6.
0.6.
So using this information, can you calculate? I'm giving you 2 minutes and let me know whether you are getting the, in terms of FZ only. Okay, I'll be back in 2 minutes. Okay, just solve this and let me know.
Point 0.83.
Shouldn't it be 1 minus fz of 0.83?
Yes, that's
Okay, did you get the FZ values?
0.83.
In some GA, we are not given with FZ, then what? So Madhav, actually, graded assignment is parameterized, so it's not possible to give you all the values. So if you can basically search on the Google, let's say Z table, FZ table. Okay, so you will go here. Okay, let me show you how to say this. Okay, so if you see here, so this table is given to you. Okay, suppose you are getting FZ of 0.83. Okay,
Yes.
so you can see 0.8, right? This can you see the cursor on my screen? So this is 0.8, 0.3, 0.83. So this is 0.8, 0.81, 0.82, 0.83. So value of 0.83 is 79.7967. Yes or no? Are you getting how I'm seeing this table? Yes or no? So value of 0.83 is 0.7961. Now can you calculate and tell me the answer?
0.21.
0.20.
Okay, whatever, we'll see. What about if values of 0.2?
So this is for WLLN.
It's not about WLN. How to see the FZ values? If FZ of 0.83 you are getting, so see, if you are getting FZ of 0.83, that means I'm asking probability Z is less or equal to 0.83, right? Okay. So this is the table. So 0.83, 3 is this top. So this is 0.7967. Yes or no? Are you getting how I'm saying the values? Similarly, if I will ask what is the value of 2.2, tell me. So 2 point and after decimal you can see this value. So 2.2 is 0.9783.
So 2.2, I think we have to look down, right, sir?
Yes, sir. It is
Sorry. Yeah, correct.
No,
2.2 is
0.986.
0.9861. Yeah, thanks. Okay, so you can see it like this. So if let's say 2.4 or something like this, again you can see. So 2.41. Suppose I'm asking 2.41. So 2.4 is this, 1 is this, right? 0.9920. Okay. Anyway, abject values will be given to you. It's not like you have to see the table. Abject value will be given to you. You have to just some like let's say some 3 to 4 abject value will be given to you. You have to identify which values you are getting. Okay. Sounds good or not? So here we have to find the probability that machine will produce more than 370 bottles. Then first of all, we need to calculate the mean. So what is the mean expected value of X? 600 into zero point 0.6. That is 360.
Yes, sir.
What is the variance of X? 600 into 0.6 into 0.4. Basically 360 into 0.4. Which is
144.
144.
144. So standard deviation of X will be 12. All right. So from here, what you have to do? Probability X minus expectation of X divided by standard deviation of X. This should be greater than 370 minus expectation of X divided by standard deviation of X. Would you agree with me? Now this part I can write as a Z greater than 370. What is expectation of X? 360 divided by 12. So probability Z greater than 10 divided by 12, which is probability Z greater than 0.83. Right? Since we have to calculate the abject value, so it will be 1 minus probability Z less or equal to 0.83. Yes or no?
Yes.
And we seen values was 0.79 something, right?
7967.
So it will be 0.2033. So answer will be 0.20 because it is asking till 2 decimal places. Okay. Is this clear? Yes? No?
Yes.
Okay.
So does the chart will be
the-
given in exam? For
Sorry?
Z-value? The chart of Z-value will be given.
Some values will be given to you, not chart. Let's say I gave something like this. Let's say something fz of 0.83 values, fz of 1.33, fz of 0.22 something. So you have to identify which values you are getting. Understood?
Okay.
Okay. So let's try to do some questions and then we will. Okay. So can you try this question and let me know whether you are getting this 100 as answer or not? I can solve it, but just wanted to give you the idea because you have to solve in the quiz 2 exam.
Yes, sir.
Are you getting the answer?
Yes, sir.
Okay, let's try to solve this. Okay. First of all, what is the sample size? If you read the question, a sample size of n, 100, that means n is 100. Let's write whatever they given to us. So collected from a normal population with mean mu and variance sigma square. Suppose the expected value and variance of sample mean. That means expected value of x bar is 50 and variance of sample mean is 0.25. Yes or no? So this means variance of sample mean means you have been given sigma square by n, right? Yes or no? You need to calculate the value of sigma. Yes or no?
So, yes.
Give me a second. So now you can see, so this means sigma square divided by 100 is 0.25 because value of n is 100. Are you getting my point? So sigma square will be here 0.25 into 100, which is 25. What is the value of sigma? Which is 5 only. And from the concept, we know expected value of x bar is also mu, right? Which is 50. Yes or no? Are you getting? So expected value of x bar is mu and variance of x bar is sigma square by n. Correct? So from here, mu is 50. Correct? Sigma is 5. Then what will the value of 10 sigma? So 50 plus 10 into 5, again 50 plus 50, which is 100. Is this clear to everybody?
Yes, sir.
Yes, sir. Crystal
Oh,
clear.
okay, great. Let's come to the next question. This is MGF. Let's try to see why D is correct. If you see from here, if you see here, so we have to calculate the MGF of X bar, right? So, and you can see all Xi's are IID. So mx bar lambda will be expectation of e raised to power lambda x bar. Is this clear?
Yes.
Now, what is the x bar? It's a x1 plus x2 plus so on plus x10 divided by 10. Yes or no? If this is the case, can I write e raised to power lambda x1 divided by 10 plus lambda x2 divided by 10 plus so on lambda x10 divided by 10? So far so good. Any doubt?
No, sir.
If this is the case, exponential e raised power something, can I write e raised power lambda x1 divided by 10 into e raised power lambda x2 divided by 10 up to e raised power lambda x10 divided by 10? Any doubt?
No.
All are independent. So can I write e raised power lambda x1 divided by 10 into expectation of e raised power lambda x2 divided by 10 up to expectation of e raised power lambda x10 divided by 10? Any doubt? Since all are IID, expectations of all the random will be same. So can I write expectation of e raised power lambda x divided by 10 into expectation of e raised power lambda x divided by 10 and so on, expectation of e raised power lambda x divided by 10? Yes or no?
Yes.
Can I write expectation of e raised power lambda x divided by 10 whole raised power 10? Any doubt? And if this is the case, can I write mx lambda divided by 10 raised power whole raised power 10 or not? Can I write?
Yes, sir.
Now you can see option D is correct. Okay. Any doubt? Yes? No? Anything?
Sir, the last step. So when you say mx of lambda, shouldn't it be mx bar of lambda?
No. Why? Why? This is okay. Mx lambda. How will you define expectation of e raised power lambda x? Right. This is x. This is x. Right. So you have e raised power lambda x by 10. Right. So I will write mx lambda by 10. Right. Not x bar. Okay. See, you have simplified the x bar part. I started with the x bar.
Got it, sir. Got it. Sir.
Right.
Sir, can you just move up once, please?
Mhm.
To the previous problem. Sorry, I had a silly query.
Okay.
Yeah. So in this one, since it's mentioned, find the value of mu plus 10 sigma. So mu is basically E of x, right?
Yeah. E of x.
Okay. No,
So
I had this small
E
confusion.
of x is mu.
Mu.
And variance of x is sigma square, and we know for IID samples expectation of x bar is also mu, but the variance of x bar is sigma square by
n.
right?
Fine.
That's why I told you those properties are very important, right? If it's in your mind, you will do the question within a minute.
Yes.
Yeah.
Actually,
So,
sir, the practice time is very short. That's why we can't properly remember.
That is something you have to manage from your end. Okay. So this question I think we have done. Okay. I solved it. This question also we did. You can check the things whatever I wrote is it was not saved, but yeah, you can solve it and you can try it. This is also we have done. This is also we solved. So this property is again very helpful. This expectation of x bar is mu and variance of x bar is sigma square by n. Again, I'm saying this is very important for your exam as well as in real life also. Okay, this is something you can keep in your mind. Okay, this is something we did. Okay, yeah, this question. Okay, tell me. All right. So x is the discrete random variable with following PMF is given to you 0, 1, 0, 1, 2 with success with probabilities 1 by 4, 1 by 2, and 1 by 4 respectively. So x1 comma x2 is IID x. You have to define a random variable y x1 plus x2. You have to find the MGF of y. Which option is correct? Can you tell me? Just you can take 2 to 3 minutes, solve it, and do let me know. Are you getting?
So last one is correct.
Solvent, sir.
Last one. E.
Yes, sir.
Sir, A.
Last.
Okay, A is correct and last is correct. These two are correct option. Okay. A is also correct. You can write mx1 lambda into
Yes.
mx2 lambda, right? And
Correct.
later you can write, since this is ID, mx lambda into mx lambda, both will be same, and it will be mx lambda square, right? So this is final step, but I can write this one. Yes or no?
Yes.
Yes, sir.
Okay. So let's try to see the last one. So to solve this, how did you proceed? You convert first. So there are two approach. You can find the distribution of y, and then you can calculate, right? Or else you can calculate the mx of lambda, and you can do the square of it, and you can find the answer. Yes or no? So
Yes, sir.
I would like to go with mx lambda, because why I will spend my time to calculate this y and all. So what is the mx of lambda? If you see, x is 0, 1, 2, with corresponding probabilities is 1 by 4, 1 by 2, 1 by 4. I think these are the values. Yeah, correct. So what is the mx lambda? Is nothing but expectation of e raised power lambda x. Give me a second. Sorry. Okay, so this will be then what will be the, it will be e raised power 0 into lambda into 1 by 4, correct, plus e raised power 1 into lambda into 1 by 2, plus e raised power 2 lambda into 1 by 4. Yes or no?
Yes.
Correct. So at the end, so it will be basically 1 by 4, because e raised power 0 is 1, and e raised power lambda into 1 by 2, plus e raised power 2 lambda into 1 by 4. And what I have to do, I have to square it, right? So square of this, it will be, and you know, a plus b plus c whole square, what is the value? A square plus b square plus c square plus 2 times of ab plus 2 times of bc plus 2 times of ca. So you will get the final answer, this answer. Okay, is it clear?
Yes.
Also, so there is last question. Okay, what about expected value of y? How will you calculate? If you have the mgf of y, my lambda, as let's write like this: 1 by 60, 1 by 4 e raised power lambda, 1 by 16 plus 1 by 4 e raised power lambda, plus
3 by 8 e raised to 2 lambda.
Okay, plus
E raised to 3 lambda by 4.
1 by 4 plus 1 by 16.
1 by 16 e raised to
Right.
4 lambda.
So what is the PMF of y? It will be 0, right? Because it will be 0 into lambda. 1, 2, 3, 4. Yes or no? What is the
Yes.
probability of y? 1 by 16,
16.
1 by 4, 3 by 8, 1 by 4, 1 by 16. Now you can calculate the expectation of y or not?
Yes, sir.
Okay.
Yes, sir.
Is this clear?
Yes.
So you'll be uploading this paper, right, on the dashboard?
Yeah, I will be upload under the live
Supplement.
session section,
Live
right?
session. Okay.
It will be 2.
Okay. There is last question. I think this is something this problem, similar problem I did in by taking example. If mx lambda is this, what is the PMF of y? Sorry, x.
You just do the back calculation of it, sir. Just.
Yeah, tell me which option is correct.
-1, 0, 2,
6.
and 4.
Option B is looking like that.
Option B is the correct one.
Yes,
See,
sir.
within a minute, within a second, you will get the marks. Okay. So I will upload this PDF. I'm sorry about this PDF. My system got stopped in between. I don't know why. So actually, we are done with the content and also. I hope you have learned something regarding week 7 and week 8. Is this okay? I mean, did you get the concept? Did you get the idea, everyone?
Yes, sir.
Oh.
You are the sir only instructor whose session I have enjoyed the most.
Okay, thanks.
Yes, sir.
Okay. Then, is there anything else? Yes, Devangi.
No, sir. By mistake, I raised my hand.
Okay, all right, no problem. Anything else?
Sir, one question. I have forgot the solution, sir. You have solved today the sample variance of mean. I think the question can you open? There is
Okay.
some options given.
Which question?
Sample variance of the mean.
Sample variance of the mean.
this one.
हाँ.
सर ये आप कैसे निकाल रहे थे एक बार
See, it is variance of the sample mean. That means I'm talking about variance of x bar. This is sigma square by n by the formula. Right. So what is the sigma square? In the question, sigma is given to you. Then what is the sigma square? 0.4 square. So if n is, it is asking what is the effect, right? If n is decreasing 64 to 25, if n is 64, then sigma square 64. That means 0.4 square 64, right? So value will be 0.0025. I'm just checking from here, taking directly. You can cross check. If n is 25, then sigma square 25 and 0.4 square 25, which is 0.0064. So this option is correct. So this is again, this question is kind of important question.
So sir, here no use of the mean mu.
No. It was just given the information, basic information.
So sometimes some thing is given in the question is of no use.
Correct. That's possible. That's possible.
At this point I have sometimes confused.
No. So you have to see. You have to use the values which is required. That's all. Okay. So question will be framing like this. Sometimes whole information will be given to you. You have to identify what information you have to use to solve any particular problem. Okay.
Yes, sir. Yes.
Oh, all right then. Thanks all. I hope you got the concept. I will upload the PDF on the supplementary content and live session notes. Okay.
Thank you, sir.
Thank you, sir. Thank you. Bye bye.
Thank you, sir.
Bye, sir. Have a good day.
Same to you. Bye.
Thank you, sir.
Thank you.